Hi guys, you're not gonna believe me, but this question, power of 3, that's a LeetCode easy question, was asked more than 53% time in the last 3 months in Google. So let's see if we can solve this quickly. So this is a pretty simple question, like you are given an integer n, you have to return true if it's a power of 3, otherwise return false. So like let's just understand by the example. 27, like we can write it at 3 to the power of 3. So we can directly say the 27 can be written as a complete power of 3. That's why it's a correct answer. So we'll return true. If suppose the number was something like 15, like it's 3 into 5. So it's not a complete power of 3 because there is a multiple of 5 also. So we can't say the answer is true here, like then the answer is false. Similar case with this kind of cases. No power of any natural number can give us 0, or no power of any natural number can give us -1. So like, and we can cover this case also. For suppose n was 1, so we can say 3 to the power of 0 is 1. So this is also a correct answer. So one of the simpler approach is like we can use the fact of I can say modular operations. I can say majority of the divide questions like can be handled using modulo if you try to see it once. So suppose like I can just give a simple example here. Suppose the number was 15, it can be written as 3 into 5. So if you divide this number by 3, the remainder is not equal to 0. You can see the remainder will be kind of 2 here. But if you divide any power of 3 with 3, the remainder will be 0. Like suppose the 27 was we divided by, you can directly divide it by 3 to the like 9. So you will get the answer as 0. So I guess you can kind of think of in this way, like if we keep on dividing the number by 3, if it is divisible by 3 and like the modulo is giving me 0, this means it's divisible by 3, and now I divided by 3. So if at last I'm able to reach 1, like suppose the case was 9, like I keep on dividing 27 by 3 till I reach 1. If I'm able to reach 1, this means like I'm able to get it as a complete power of 3. But like it won't be the similar case with another number. So the simpler approach can be here, like I can say we can, using these two base cases, I can directly say if n less than equal to 0, we can directly return false because no power of any natural number will give me 0 or -1 or any negative answer. So I'll keep on dividing. I'll first of all keep on checking like if this number is divisible by 3. If it is divisible by 3, then only I divided by 3, and doing this process till if I'm able to reach at 1, then this means like this was a complete power of 3. Because suppose in case of 15, you will like first of all it's modulo by 3. 15 modulo 3 is like first of all 0, like but like now n is, if we divide it by 3, then now n is 5. So if you check 5 modulo 3, this is not equal to 0 and n is not equal to 1 here. So this is a false case. So I guess you are able to get this kind of solution, like, but like there is also one more approach, like that is O of 1. Let's also try to handle it using modulo operations only. So suppose your given number is, I can say, complete power of 3, that is n is now 3 to the power x. Using the same modulo operator, we can say if we modulo it with the largest power of 3 in this 32-bit range, because we can see like the conditions are here for 32 bits. So you should be able to get 0. So suppose that like if we check for 32-bit, the largest power of 3 is 3 to the power 19. If you divide it by some power of x, now x is here less than 19, like we can also keep an equal case for the I can say edge cases. So it will always completely divide it. The remainder would always be 0. So using this fact, you can directly say it like, first of all, the base case is less than equal to 0, return false. This is 3 to the power 19. If any natural number is there that is giving, that is after moduling giving me 0, this means the number was a complete power of 3. So do let me know if you were able to guess this answer, and like for any improvements and all, you can just comment it. See you in the next video. Thanks.